forum on the challenges of offshore communication. Thank you everyone for joining us today, and thank you especially to all of our speakers. Today we're joined by 8 fantastic industry professionals, 4 from the maritime sector and 4 from the satellite communications sector, as well as Sean and George from Satellite Applications Catapult, who have helped to organise this event. The purpose of this webinar is to discuss the current challenges and solutions in the maritime SATCOM sphere, as well as enabling cross-sector introductions and networking. So just to give you a brief overview of the running order for today, we're going to start with a brief introduction to SMI and the Satellite Applications Catapult, followed by the 4 maritime presentations from Fugro, Thales, Dendriska and Autonaut. These presentations will be followed by a discussion and Q&A on the priority of current offshore SATCOMs challenges. We'll then have a brief coffee break before the 4 satellite communications presentations from OneWeb, Inmarsat, Avanti Communications and Douglas Watson. These presentations will again be followed by a discussion and Q&A session, this time on the solutions and the future of offshore communications. Before we start, I'd just like to go over a few housekeeping details, although I'm pretty sure we're all Zoom experts by now. If everyone can just keep themselves muted throughout the presentations, just to limit the background noise. And as we go throughout the presentations, please feel free to type your questions into the chat function, which should be at the bottom of your screen. And then when we come to the discussion and Q&A, we'll be able to answer those questions. And also, if you want to expand on them, we can always ask you to unmute and expand on your question if you want to. And just so everyone's aware, I'm recording this session for the people that couldn't make it today, so the recording and the slide pack will be available afterwards. So to start off, I'll just give you a brief introduction into myself and SMI. My name is Emma Johnson and I'm the new Business Development Director at SMI. Our members in the audience might have noticed that we've rebranded. This rebranding launched this morning, so you're all amongst the first to see it. The process of analysing the brand and the values of SMI has given us real insight into the way we communicate and act, and the team is feeling refreshed and focused to deliver our core ambitions and statements. So the Society of Maritime Industries is the voice of the UK's maritime engineering, technology and business sector. We promote and support companies which design, build, refit and modernise ships, and supply equipment and services for all types of commercial and naval ships, ports and terminal infrastructure, digital technology, maritime defence and security, marine science and technology, maritime autonomous systems and marine renewable energy. As a trade body, SMI provides innovation and insight and engages with government to advise on the maritime policy in the UK. Our main purpose is to profile and promote the UK maritime and marine science industries while collaborating with other trade organisations. We enable our members to network with other members as well as with external groups in forums such as this one, or in more normal circumstances in person. Just to give you an idea of the industry we represent, here are the main statistics. So the industry has a turnover of £14.2 billion and employs 81,900 people. The total export of goods and services for the sector is £1.7 billion. In order to achieve our mission and aims, our activities are wide-ranging. We hold UK seminars and conferences like this one. We represent the UK at international exhibitions through our UK pavilions, and we continuously work with government and other bodies such as Maritime UK to lobby on behalf of our members. At SMI, we've created 6 sector interest groups with relevance to our members. They are the Commercial Maritime Operations, the Marine Science and Technology, Maritime Autonomous Systems, Naval and Maritime Defence, Digital Technology, and Ports and Terminals Infrastructure. These groups further enable networking between members large and small. So thanks very much for listening to a brief introduction to SMI. Please do not hesitate to contact me if you have any questions or you're interested in joining. I think you all have my email address, but if you don't, it's on the screen now, and we'll be sharing this afterwards. So
Jason, does that?
Could everyone make sure that their microphones are on mute, please? Just reduce background noise. Thank you. So now I'm going to hand over to Sean McCarthy from Satellite Applications Catapult to give you an introduction into Satellite Applications Catapult and what they do. Sean, over to you.
Thanks very much, Emma. And first of all, I'd like to thank the SMI for arranging this kind of event that brings together, you know, one of the most important end user communities for the space sector, and you'll see in a minute that the role of the catapult is to make sure that we make these relationships between different industries and different sectors. That's our main thing. I'll just say next if you go to the next one, please. So the catapult's been around for about 6 years, and I think probably most organizations within the space industry are familiar with us. But for those who aren't, or who are from the maritime side, we're funded predominantly by the government, even though we can do projects and research and receive commercial funding. But we are independent, and our independence is really important because it does enable us to do these kind of community building activities, which I think is so important. One of the challenges that we see in the space sector is traditionally there have been a relatively small number of customers like the government or science for satellite services anyway. And now, as new space comes along and commercial opportunities are being developed, it's important that all of the various stakeholders have the opportunity to mix with each other and find out what the challenges are, and that's what we're here to do. So next, if you may. Okay. So the catapult's interested in the whole range of space and satellite services, so from GNSS or positioning, Earth observation, weather data, but one of the key areas that we're particularly interested in is satellite communications. And we're, as the applications catapult, we're primarily looking downstream at what you do with these services. Now, there are far too many markets for us to cover. We employ about 150 people when we're working in Harwell. We obviously we're all working from home at the moment, but we've got expertise in specific markets, such as intelligent transport, and that's sort of about ubiquitous communications between cars and infrastructure, as an example. Sustainable living is looking after agriculture. The last one on the list there is government services. So we're doing quite a lot of work with connectivity between hospitals and ambulances, and getting health services into the community, particularly in remote areas. But the blue economy bit is something that I looked after at the catapult for a number of years. And if you just go next, I'll come to the next one. And it's covered a wide range of services in the blue economy. From we're doing illegal, unreported and unregulated fisheries monitoring. We're looking at coastal monitoring, but also this is why I'm so interested in today's discussion about offshore connectivity as well. If you could just go on to the next one, please. There you go. One of the key things I always try and get across is how that the satellite industry has been part of the maritime community since the satellite industry's inception. Really, it's you know, the original SOLAS communications, the positioning, weather forecasting, all the marine science. That's the satellite community's been right there from its early days, and it's very important for the satellite services to understand what are the future needs of the maritime sector. And so being no particular expert, but understanding that in the maritime sector there's a great drive for the sort of more use of digital services, digital technologies. Autonomy is on the horizon. How do you communicate with assets remotely, the issues around energy and environment in terms of a movement away from high polluting fuels to maybe electric vessels in the future, and how you manage those, all will require sort of over the horizon communications of some sort or other. And that's, at the moment, that's where satellites are playing a key role, and actually have done for many years. Next, please. Are we going on? Okay. This is probably not legible, but the slides will be made available afterwards. All I did there was just list some of the things that the maritime community use satellite services for, and you can sort of tease out the bits that are about Earth observation or weather services. But comms is used in virtually everything, and probably even in marine spatial planning. There'll be remote sensors that are linked together by satellite communications. I thought I'd put in a picture of the Autonaut, which you'll be hearing about later. But sort of moving forwards in the maritime world, just seems that satellite communications are going to become more and more relevant. And if you go on to the next one, then we'll have a quick look at what's happening in the satellite sector. I'm not going to go into the detail. They're much greater experts in the room than me. But what the key point I wanted to bring out here is that there's been a high amount of investment in infrastructure, and then how you get the signals back through the ground stations and development of antennas and other technical services is an ongoing aspect, but also more and more applications laid on top of the infrastructure are extremely important. So the services that or the solutions that handle satellite data and take care of the sort of things like billing or switching services between different satellites. So all of these things are important, and obviously the developments of infrastructure by organizations such as Inmarsat. We hear about what SpaceX are doing, what OneWeb's doing. We're going to hear about that later on. But the importance that even if organizations have used satellite communications in the past, and the services being provided are not static. They're changing all the time. There are new services coming on board, and the purpose of events like today is to get that sort of technology cycle going, whereby end users feedback and say, well, actually what we're looking for is this kind of service or X, Y, and Z. And that's the purpose of today, to stimulate discussion, debate, and try and get products being developed that the end users in the maritime world will be able to use at the right price, in the right place, and the right technology. So that's my brief introduction, and if I can hand back to Emma. Thank you very much.
Thank you very much, Sean. That was a great introduction. I'm now going to hand over to our first maritime company for today, which is Fugro. We have Alistair McKee with us. Alistair graduated as a Bachelor of Science in Geographic Information and Mapping Sciences from the University of Glasgow. After that, he worked as a land surveyor in the UK for 2 years. He then moved to Fugro and worked as a hydrographic surveyor in Perth, Western Australia. Moving back to the UK in 2010, he continued working with Fugro out of Aberdeen in a variety of positions offshore until moving onshore in 2018 as Director Positioning and Construction Support for Europe. In 2019, he was also made responsible for all the remote operations throughout the Europe-Africa region in his additional role of Director Remote Operations Europe-Africa. Alistair is also a member of the Chartered Institute of Civil Engineering Surveyors. Alistair, over to you.
Thanks, and yeah, apologies for the wordy bio, but yeah, it's a pleasure to talk in this environment. I mean, I guess I really want to get across the challenges of offshore communications from the perspective of a remote operator. Perhaps you can just go on to the next slide. and the next one, and the next one after that. Yeah. So, I mean, really, when we talk about remote operations and the communications requirement, we need to go back to what we're actually wanting to do with it, because communications means a lot of different things to a lot of different people depending on the application. Even if I think back to when I started going offshore, 10, 12 years ago, if I was to say, well, has the vessel or has the asset or has the rig got communications, the answer would have been yes. But what they would have deemed as appropriate communications 10, 12 years ago is very different to what we get now. 12 years ago, I would have been happy with a satellite phone that had to go up to the bridge, stick my head out the window, pull an antenna up and have a fairly jittery conversation with somebody on shore and try not to get hacked off at the latency between the two. Whereas now it's a very different world, certainly offshore. The majority of the assets are now far better connected than they've ever been. And people tend to make use of that in a far more advanced manner than we've done before. I guess within Fugro, we are one of the world's leading geodata specialist companies. So really geodata is our business, and the geodata that we typically collect, we acquire, we analyze, and then we provide advice based on it. It is in fairly unique and remote places. And specifically, if I look at the work that I personally am involved in, it's all marine and offshore type data, both on the surface and below the surface of the water, and then below the surface of the seabed again. And that presents a number of different challenges to how we deal with that. If we look at the way that the whole business has gone over the last 20, 30 years, it's very much focused around big assets with lots of people on them, collecting and acquiring and analysing this data. Whereas if we look at the way we want to be doing business in the future, we want to be more intelligent, we want to be using more remote and autonomous solutions with less people offshore, which is a far more sustainable way to go about it from a people and personnel perspective, but also from an environmental perspective. And I think we've developed the world of being remote operators, which I think is quite a diverse shift to how we operate. And really by that, I mean we have a network of remote operations centres, or ROCs, if you like, around the globe. We have a number of them scattered in conveniently located places that are connected to our assets offshore. And our assets are typically vessels, they are rigs, they are moored buoys that monitor weather, that kind of thing. And all of this data that they collect and acquire needs to be sent ashore, and needs to be sent ashore in a timely manner. So really, we span across lots of maritime sectors, renewables, oil and gas, power and infrastructure, collecting all of this data. And we want to be able to transfer it all to shore, and then from shore to our clients, wherever they may be, and in a timely fashion. I think if you go on to the next slide, and again, as our challenges as remote operators really are focused around a number of different areas. First of all, I guess the challenge is what type of data, what are we trying to transfer, and how do we do that? When do we want it and where do we want it? I think it's an important part. How quickly do we need it? Because again, there's a cost impact to that. I mean, I think Sean made a good point just in the presentation earlier, in the sense that, yeah, anything is possible, but it needs to be at the right price. And obviously, we need to ensure that we are still commercially viable. And then what about latency? And when I talk about what we are doing with data, latency becomes very important in a lot of different scenarios. So if you move on to the next slide, I mean, I think initially, as I said at the start, comms means, the term communications and offshore communications means a lot of different things to a lot of different people. All of our vessels, our rigs and our assets are connected in some manner, but that can mean anything from being connected such that they can make a phone call or send an email, to being connected such that they can stream audio and video in real time, backwards and forwards, to be connected such that we can take control of machines, so cranes, remotely operated vehicles, the vessel itself. In some instances, we're now moving into the uncrewed surface vessel, where we need to take control of that, and that requires a different communications network. So really, we're looking at the challenge of having the requirement to transfer anything from 500 kilobits to 80 gigabytes a day off of one of our vessels, typically from the middle of the ocean, and potentially with no people on board. I talk about, the requirement for real-time data and near real-time data. There are some things that we need in real time, and there are others that we don't necessarily, but we need in near real time, so fairly soon after the fact, but not immediately. And again, that has an impact on the technology that we can use currently, and indeed the cost of it. And I guess an example, as I said at the start, could be diagnostic information for the systems and the sensors that we have offshore. Machine control, we could be controlling cranes, vessels themselves, remotely operated vehicles, so robots underwater that may be engaged in subsea operations with other structures or client infrastructure. It could be simple things like weather data, sensor data, video streaming and audio streaming, which I mentioned. It could just be a case of transferring a load of data back to shore to be dealt with onshore. And then you've got the really simple things that are often overlooked, especially if you're looking at the comms challenge on a vessel or a platform, is that, yeah, whilst we still have people in the offshore environment, there's an element of vessel admin and project comms that are required, and they require different types of communication solutions to meet that task. If you maybe move on to the next slide. I guess when and where becomes really important. We operate, as I said, globally, all over the world, with regional remote operations center facilities. So we want to be able to get the vessel from the data from a vessel, whether it's in the UK sector of the North Sea, whether it's off the coast of West Africa, whether it's in South America off the coast of Brazil, anywhere. I want to be able to get that to a remote operations center as quickly as we possibly can in some instances, to be able to feedback and control and make good decisions off that data. Obviously, you've got the offshore element, and part of the benefit around remote operations for us is the fact that we bridge the gap between our offshore and onshore environments, and that can lead to far more efficient project execution and decision making for ourselves, but also for our clients. But to do that, that link becomes so important. I mean, if you just think back to the kind of infographic we showed before, to be remote operators without the offshore communication part solved, we cannot do the job, and that's how critical it's going from being. And I think that's a really important point. We've gone from offshore communications was a nice to have because you can send an email, you can get an update in the news, you can check the football scores, whereas now offshore communications is becoming mission critical. Without it, we are all stopped, and there's nothing we can do. And I think the redundancy and the requirement for that backup, both duplicate and triplicate of systems, becomes really quite important. I mentioned the requirement to have efficient hardware, and really we need to make sure that we have efficient hardware on our assets offshore that can intelligently switch between the most efficient or the most appropriate method of communications. Now that could be 4G, 5G, VSAT, or potentially in the near future low Earth orbit satellite type information. But we need to be able to have a streamlined setup on a vessel to enable the hardware to intelligently switch between the best communication method for the comms requirement that's there. And perhaps one thing that a lot of people maybe don't think about straight away, but the minute you start talking to any client involved in passing data around, the security of the data becomes absolutely critical. We want it to be accessible to everyone, for sure, but only those who are authorized to do so. So, I want to be able to share the data that we collect from the seabed in near real time with my client, who could be sitting in Norway, who could be sitting in Nigeria, who could be sitting in Houston. And I want to do that near real time, but I don't want to share it with anybody else or have anybody else with potential access to that data. And the security protocols around that become really quite challenging, especially when you consider the types of data that we are dealing with. A lot of it is fairly confidential and sensitive towards our clients and their stakeholders. Perhaps the next slide. I mean, one of the questions has been, how quickly do we need it? And the answer is as quick as we can get it, but within reason. And it really does depend, complicated enough, on what we're trying to do with it. There are some instances where we need real-time data, where, for example, we are controlling an asset. We are maneuvering a vessel like the one you see there, which is a picture of our uncrewed surface vessel. We need that in real time. We can't afford to get that data late, and it needs to be constant. So I mentioned the 99.9% uptime, and that's really on the basis that, yeah, I think 100% uptime is a bit unrealistic. But that becomes so critical, and it's mission critical as well. If that goes down, we cannot operate our systems. So the backup and the redundancy and dedicated systems to that become really critical. But at the same time, whilst we need all of that data really quickly, there are perhaps some elements of data that we don't need so quickly. So that our systems may go offshore to acquire lots and lots of data. I mean, I mentioned the figure of 80 gigabytes earlier on, but I may require 5 gigabytes of that straight away. And the rest, of, the other 75 gigabytes, I can trickle back to our facilities onshore at a more efficient, in a more efficient manner. And that really is the challenge as to how we go about it. I mean, we typically, at the moment, we operate on connection speeds of our VSAT systems from anything from, half a meg up and down to over and above 10 meg up and down, depending on the requirements of the project, the vessel, and the mission that we're doing. And once you get into the contracting mechanism behind that service provision, it actually becomes quite complicated and can be quite expensive depending on how you want to do it. Perhaps the next slide. And really, this is the old question that always comes up, especially when we talk to a lot of our clients that are within the offshore maritime industry, where they talk about latency. So latency, to give you an idea, if we're controlling a manipulator or a crane or a vessel, becomes really important. So we need a means of minimizing latency to as low as practically possible. And obviously, if we're going via VSAT, there's a physics limitation in there. But every millisecond in that computation and that path counts. However, that's not to say that we need all of our 80 gigabytes of data that day with as low a latency as required. We need immediate real-time feedback, so low latency on some of it. But there are other parts of the operation and the mission and the data requirements that we can pass back at a far higher latency, where latency does not become so critical. So again, machine control, crane, ROV vessel, latency is critical. We absolutely need that. If we're operating over VSAT, we need that latency figure somewhere around the 540 milliseconds, which is pretty much the limit of physics, give or take an element of contingency. But then again, for data transfer, for email, for voice over IP, all that kind of comms, it's not so critical. And that really is the challenge in coming up with a communication system and an error budget almost for the comms that's there. It's really hard to get one size fits all. I mean, just to go back, when we started talking about remote operations years and years ago, we sat around a table with a lot of our key stakeholders, and the biggest challenge in rolling out remote operations for us was perceived to be the communications. And by that, I don't mean, the physical talking to each other about it. I mean the physical, how do we get this data back? I actually, from the work we've done over the last few years, I'm pleased to say I don't see it as being the biggest challenge, because I think that the industry's moved on so quickly in that area, and an economically viable pace as well. I think it's all possible, but there's still some work to be done on the economics. I personally think the biggest challenge in rolling out remote operations is actually the human element behind it, and the fact that people actually don't want to change all that quickly, or the human change management process is a very complicated one. And I guess just on to my next slide, and to go back to our geodata roots, in the sense that, yeah, our planet's a complex system, and unfortunately for remote operators like Fugro and many of our peer organizations, our communications requirements are just as complex. There is no one size fits all. There is no silver lining as such. We need to have a combination of systems that are very much design mission specific, which does challenge the cost ratio against the service we receive. And I guess really that's the message I wanted to get across. You know, a few years ago, we would have seen communications as the biggest challenge in remote operations. I honestly don't believe that's the case now. However, it remains an absolutely mission critical component of which we need to keep on pushing the boundaries. And that's certainly at the forefront of our minds.
Thank you very much, Alistair. That was brilliant. I'm now going to hand over to Matthew Hunt from Thales. Matt is the UK product line manager for mine countermeasures within Thales Underwater Systems. The role is responsible for the sustainment, delivery and future strategy and investment for all MCM products. This recently has included the expansion of the unmanned systems portfolio, including the unmanned surface vehicle and sensor payloads. Matt is a chartered engineer and spent 22 years serving in the Royal Marines, deploying on operations around the world, qualifying as an artificer telecommunications in 2013. Matt spent the final 4 years in uniform in the C4I Capability Development Officer for the Maritime Unit, developing and delivering maritime and littoral capability, air, surface and subsurface through the CAD-MID cycle. Matt, over to you.
Thanks very much. Sorry for all the acronyms in the intro, ex-military, and it's a hard habit to break. So Hadal Zone to Exosphere and back. Emma asked me to present on that. Once I'd gone away and actually found out what that meant, I thought it was a really good topic, and it's something that I've been quite interested in. And just to commit a bit of heresy just before we even start, I mean, satellite communications, you know, is it the future? You know, some of the slides you're going to see now about, you know, mass of unmanned systems at sea, you know, could they all be 5G networks in their own right? Could they all be connected? Could we be using them to conduct communications rather than satellites? I'm not saying that is the solution. I'm just saying that's something that needs to be discussed. So an artificer telecommunications, my specialty is communication systems, networks, and information pathways. So why am I a Royal Marine in charge of mine countermeasures, especially in the unmanned domain? Because everything is now about data. The right decision maker, sorry, the right data to the right decision maker at the right time. So next slide, please. So once I figured out what Hadal Zone to Exosphere was, I put this presentation together internally inside of Thales about 2 years ago, and my colleague Chris Wardman's on the phone now, and we both do with maritime autonomy. And satellite to seabed was how I said it inside of Thales, and I was very keen that people think of maritime autonomy in a very one-dimensional, it's a surface vehicle or a subsurface vehicle, but that's not actually the truth. Sorry, I've just got a thing on my screen saying I'm unstable. Am I still okay?
You're fine. Yeah, you're fine.
Okay, good. So what you can see here on the screen is a very defence-heavy slide, but it's also got offshore renewables and satellites, and it's got surface vehicles, subsurface vehicles, airborne vehicles, and I think this is one of the challenges for me. One of the things I think gets missed with these communications type of discussions with unmanned systems is that this is how we are going to deploy them. There will be mass at sea. So how are we as a satellite industry going to control, operate and maintain these systems? How are we going to get that data? And Alistair's presentation was really good, and we haven't colluded, because some of the stuff I'm going to talk about today is exactly what Alistair said. So I think there will be a common theme throughout all of this. And how do we challenge our doctrine and our concepts? Chris and I, for example, have been working on a program for offshore wind stations. How do we inspect them? How do we go out and look after them from a maritime autonomy point of view? Now, I'll sail my unmanned surface vehicle out, I will launch my unmanned air vehicle, and I will do an inspection via advanced cameras and LiDAR and potentially X-ray. But that's wrong. Why would we take the unmanned surface vehicle out? Why would we launch a drone? Why wouldn't we have a robotic spider living on the wind turbine that just crawls all over it at the right time when it's down and does the surveys, then passes that data back. So we really need to start from a clean piece of paper, I suppose, is what I'm saying with maritime autonomy. You know, even now with inside of Thales, we're having to design our surface vehicles to host people, because culturally we are not ready to launch these things at sea over the horizon on their own, multi-million-pound platforms potentially. So this is all about, if you've seen me talk about unmanned autonomy before, it's about trust and technology and time. And that is a really important part of this. And I liked Alistair's part as well about communications. You know, in the military, communications now are a no-go criteria. If you haven't got communications, you will not go on a mission. And I think this is exactly where we are with this. So we need to develop a robust and resilient communications package, and I'll talk about some challenges later. And there's a mnemonic I always use when I'm developing an information exchange requirement, where I need to have a primary, an alternate, a contingent, and an emergency set of communications to give me my resilient and redundant network in order so I can operate these systems. Okay, next slide, please. So just to finalize that first point, the second part of that, which if you saw was the padlock around the edge, was the security of those systems. Now, whether they're military or whether they're commercial, you do not want people getting on board them. You do not want people taking control of them. You do not want people getting hold of that data. So they need to be protected and secure. And then the other part of operating these systems is the back end. We need to have these communication centers, operating centers, remote operating centers, whatever we want to call them. Now, they can be on ship and deployed, but they're most likely going to be ashore-based. And that goes back, Sean, to your smart ships and the 2040 vision strategy and how we're going to do ports. So we need to have multiple interconnected ground stations. We need to be able to have these monitored 24/7, 365, because that is the joy of maritime autonomy, is that it operates in a dirty, dull and dangerous. It's persistent. You know, these aren't things we put to sea 9 to 5. They will be out there 24 hours a day working. You need to be able to disseminate the data globally. So these need to be connected and they need to be secure. Like Alistair said, the right people getting the right information at the right time. We need to build that information database, because everything we're harvesting now needs to be used, because we can then use that in synthetic environments to prove that the autonomy we're going to use is now applicable. We can prove that it will do what we want it to do, and we can build our AI. And again, that goes back to latency, that if the latency is too high, the artificial intelligence running these systems at sea will see it as a threat or will see it as inappropriate data. So we need to be fingerprinting our data. We need to be running distributed ledgers, blockchain. We need to be sharing data amongst swarms of these unmanned systems. We need to be cyber certified. There will be a requirement to have obfuscated and protected data, and we need to be able to do that over a single pipe. Now, whether that's satellite or broadband IP, 5G, it doesn't really matter, but we need to be able to do that. And we need to have commercial availability. So we need to be able to make sure that we can operate across multiple types of satellite. And the thing that's come out this week, and it was in Alistair's, and Chris, my friend, talked about this week, was the ability to hand off these systems. So when you're taking it out of the port, you'll be running on a 5G, you might be running on a line of sight broadband IP network, but then as it gets beyond line of sight, you'll need to hand that over to satellites. And how do you do that? And how do you do that in a way that the system doesn't start breaking down and thinking it's being attacked? Next slide, please. So I thought I'd just list out some challenges as I see them. Satellite to seabed, obviously we're into an acoustic domain below the surface. We now need to gateway between subsurface and surface. I've worked on a program in the past where I was talking about Ubering submarines. So an iridium to acoustic modulation, and therefore I can just call on a submarine via an iridium network. Bandwidth is going to be really critical to this. How do we manage the amount of data? If we're pushing live sonar data or high definition video or radar over these, they're going to be really bandwidth intensive. The quality of service is going to be really important. We really need to keep that quality of service high. High integrity circuits, so the command and control, like Alistair was talking about, for a manipulating arm or a surface vessel at sea, that command and control cannot fail. But the sensor payload data, the video or the sonar, could be sacrificed in order to make sure that we have high integrity circuits, so we don't lose control of our manipulator arm at a really important part. Power balancing is always something I've struggled with. If you've got these things at sea for a long time, and the power balancing manager will turn you down and you'll drop off the network, and then you'll be ringing him up and you'll say, well, why did I drop off the network? Oh yeah, I've just power balanced and you've dropped off. Now that might be a bit legacy, but that's the sort of problems I had. Homogeneous and heterogeneous. So are all of our unmanned systems the same, or have we got a real mix? And if we've got a real mix, not only have we got a mix of subsurface, surface and air, but we'll also have a mix of sensors on those individual things. And now we've got different payloads running different formats, running different bandwidths, and it can get quite complicated. Swarms we've spoken about. Cost is always an issue, and I think one of the challenges for the industry will be about smarter commercial models. How can I turn it on, turn it off, you know, pay as I go? I've got a limited amount of data that I can run up to. I think that's going to be a new way of doing things. Latency, I think we've spoken about enough. The satellite acquisition time as well is going to be really complex in that maritime environment. In the far north or the far south, you know, acquiring that satellite, getting that satellite locked and maintaining that quality of service. Persistence I've spoken about. Security is going to be critical for data in commercial or in maritime defence. How do we stop people spoofing our systems? How do we stop people jamming our systems? And then hardware, the size, weight and power of these satellite terminals, you know, needs to be commensurate with the size of platform that it's on. If I'm using an unmanned air vehicle at sea and I've taken up all of its payload lift with the satellite terminal, well then I've got no capability. And all of this in the most challenging environment in the world. So IP ratings are going to be critical. The ability for it to not get affected by water splashing all over it, and the ability for it to stay out at sea for a long time is going to be key. Next slide, please. So what I thought I'd do is I'd sort of bring all my my presentation together with a real world example. I've been reading quite a lot lately on the quantum cable, and it's being installed in this region, and it will connect subsea 7,700 kilometers of cable across the whole of the Mediterranean, and it will carry 60% of the world's internet traffic. Now, subsea warfare, subsea maintenance, sustainability, whatever, whether you're a commercial company or defense, that cable is going to need looking after, maintaining, monitoring, surveying. So how are we going to do that across the whole of the Mediterranean, share the data amongst each of those countries, with whether it's manned or unmanned systems? Next slide, please. And that's me. So any questions from me? This is a schematic of the program we're delivering currently into the Royal Navy, and you can see the complexity of the communications that's part of it. Welcome any questions now or at the end, or get in touch via email. Thanks very much.
Thank you very much, Matt. That's great. And yeah, just to echo what Matt said, if I could just remind everyone, if you put your questions into the chat function, which should come up at the bottom of your screen, if you can send those questions to everyone, so we can kind of collate the questions and ask them in the discussion session, that'd be great. Thank you. So I'm now going to hand over to Peter Collinson. Peter is the founder of Dendritica, a company focused on supporting the business uptake of net zero maritime robotic solutions through innovation. His experience comes from over 20 years in the oil and gas sector, leading a decade-long maritime autonomy strategy for BP, with a strong focus on developing robotic systems and satellite services. He also has experience of using a variety of satellite systems to support environmental, business performance and remote asset user cases. Peter's background is in marine ecology, and he is experienced in subsea inspection, environmental assessment, technology development and crisis management. He holds a PhD in marine ecology. Peter, over to you.
Fantastic, thanks very much indeed. Welcome everyone, I'll keep this relatively brief. So I think, sorry, can we jump to the next slide please? Thank you. Lovely, thank you very much. So what I want to really paint the picture of today is really how the world of maritime, mostly I think this is for the satellite companies, is really trying to add a bit more flavour to this genuine massive revolution that we're seeing in the maritime. As you mentioned, Emma, you know, my background is that I've done 20 years in oil and gas and actually worked with a lot of maritime autonomy companies to basically sort of nudge the market, for want of a better term, for what was then BP, still is BP, I hasten to add, in basically how we can transform the business from manned offshore vessels through to unmanned systems for a whole variety of different reasons. Great to see, you know, we've got Fugro with Alistair and Matt with Thales, and again, real tangible examples of how things are moving along. Just to give you a quick flavour here, you know, in the maritime world, moving from left to right, you know, you'll notice that most of these images, you know, 5 years ago, these would have all been computer-generated images. There's only one computer-generated image in here now, which is on the far right here, which are 24-metre unmanned vessels by a company called Ocean Infinity Armada, which will be, you know, they're hotly anticipated to be on the water next year. So watch this space. That marine autonomy is moving to the next stage. We've got a Fugro vessel there again, which was new as of about a year ago. Actually, we deployed that, I believe, Alistair. So on its maiden voyage on the North Sea pipeline for inspection. We've got SeaKit up there as well, and that again shows the offshore capability. And on the far left here, we've got at the top, we've got a little ASV L3 Harris unit with an ROV integrated into it, which in itself, from a communications perspective, changes the nature of what's required. At the bottom here, we've got these AUVs, autonomous underwater vehicles. The sort of Rolls Royce of it is this thing called the Hugin, 850 kilogram, multi-million-dollar sort of submarine thing that has about a 40-hour, 50-hour endurance. In the middle, we've got a much smaller unit, about 60, 70 centimeters long, and these things are called gliders. And this particular one, if you can see all the barnacles on it, this actually ran one of the world's longest missions of a couple of years, continuous environmental information. And then the right-hand side, we've got these what I would call handheld person-portable systems that are carrying a Pelican case, drop and deploy. You may want them back, you may not. The point here is that effectively there is a major transformation going on in the maritime, and it's happening right now. This is not fiction anymore, it's here and now. Next slide, please, Emma, thank you. So what does this mean? Well, I want to set a bit more context that this is not, you know, this is not the opinion of one individual. This is actually something that BP launched back in 2018 when we did what was called a moonshot. And we said back in 2018 that by 2025, 100% of our subsea inspection will be done using uncrewed systems, you know, unmanned surface vessels, unmanned underwater vessels. And that was 2 years ago. It was a bit of a punt 2 years ago, to be honest, but I'm actually really glad to say that the pace of this sector is moving so quickly that, you know, though I'm outside of BP now, I run my own consultancy. Effectively, I still think that holds really good water. And I still feel deeply and highly confident that 2025, you know, that is achievable through the way that the market is shifting and the way that technology is actually moving. Next slide, please, Anna. Thank you. Great. So, you know, what are the trends now next year? You know, what should we be thinking about from a maritime, but also from a sort of satellite provision as well? So I think pretty much we're going to learn through demonstration that I think the role of satellites, and in that I'm also including Earth observation here, because I think communications and Earth observation have for far too long been separated as completely different species. I think we need to think more holistically about what the satellite and space realm can actually provide for maritime. So I think, you know, breaking these silos down actually makes us think in a much more integrated manner. And I think to really capitalize on this stuff, that's exactly what we need to do. So, you know, I think the role of satellites is really going to push the transformation of the sector towards maritime autonomy. So what are the main trends? Well, what I'm seeing at the moment right across the different sectors is that we're moving our task complexity. Again, Matthew mentioned before our mine countermeasures. Really, in terms of tasking, you know, it's probably about 85% similar to things like pipeline inspection. So we're now moving our unmanned systems from gaining visual point data to actually doing, you know, manipulators, twisting, turning, dropping, manipulating, that whole element is starting to come in. The idea of shoaling or swarms, we're still used to using 1, 2, 3, 4, 5, but soon we're going to be using, 500, 800, 1,000, 2,000 simultaneously deployed systems. Okay, this is coming. The operations, I think Alistair really set it wonderfully around, there is a balance between near real time versus historical. And also, I think in the operations context, this idea of persistence, that these systems will be just there. They'll be there all the time. We don't need to basically, build the ship, send it out and do it. We literally buy a packet of data. And I think that shift of mindset is actually going to drive persistence. What does that mean for the satellite realm? Well, effectively, there will be more persistent, consistent demand for data services and EO services. On the data side, it's all about volume and quality. And, as we've seen already, there's going to be much more data, potentially. I think Matthew actually alluded to the fact that there's a bit of a war here going on around what I would say edge versus transmitted, processed, pre-processed. The way we've been working at the moment, I believe, a lot of it is focused around huge chunks of raw data sent to a large manned vessel. Okay, I think the future is going to be very, very different. We're probably going to do most of the pre-processing edge computing. It will be done the millisecond it is captured, whether it be cameras, whether it be pollution sensors, whatever it is. But effectively, we can see a lot of the processing and pre-processing being done on the units themselves. That then means that we don't need to transmit as much data as we traditionally do. So I think there's a balance there around, this idea of the data tsunami being a tsunami of unprocessed data. We may actually find that the tsunami is about processed data and analytics. So again, quite a different realm. And then, of course, the collection devices. As we've already heard, we have different collection devices and they're proliferating, whether those be in space, air, land, sea, the seabed, or below the seabed. The complexity and number of data collection tools we have is exponentially increasing, I would argue, at a cost and capability that is also inversely proportional. So more capable, cheaper systems, more profuse. Next slide, please. Thank you. So what's the prize? Well, basically, if we get this right, if the sectors get this right, these are the main 4 elements of benefits that we're going to see from these. Carbon emission reductions, we replace these large manned vessels with uncrewed vessels. The role of communications and trust that we need is critical for this. So, these things around latency, I'd argue that latency is sort of important now, but it might become irrelevant as we build AI systems into these robotic devices, where effectively, if it loses communications, then there are safety contingencies around the way that they operate, which is operating in the drone world at the moment. If a drone loses GPS or it loses signals, then effectively, I think that one of the issues is that you have confidence that this is not going to fly off and crash into something. It will hover, it will remain, it will not do very much until it reconnects and then moves on. It's around trust in these systems, and I think that's a large part of what we're, the communications piece fundamentally is around trust and changing people's mindsets from not trusting and having to see every second of what's going on to basically being in a position where they trust the system. They just need confirmation that the system is still doing what it's supposed to do. Safety, 0 people at sea and reduced operating risk profiles. Efficiency costs, we can do potentially more with smaller, and we can get better data as well. And then finally, the data, the volume and the quality. Because I think that fundamentally, it's all around the decision making. How is this actionable? How is it commercially viable? And effectively, how do we better manage our risk in the offshore environment, whether it be maritime, defense, whether it be oil and gas, whether it be renewables, whether it be aquaculture, whether it be cargo operations, whatever. It's all around, I think, this element of trust and remote operations. And last slide, please, if possible. Thank you. So I've tried to keep it to time, just giving you a quick overview there, and I hope it sort of sets some context. I've certainly got some questions flying up, so thank you very much indeed for the opportunity and the time.
Thank you very much, Peter. That was brilliant. Now I'm going to hand over to Phil Johnson from Autonaut, Phil heads up business development for Autonaut ASV. He worked at sea for many years as an offshore environmental consultant, specialising in the effects of underwater noise on sea life. He also has a background in cetacean research. Innovation marine technology has been a constant theme in Phil's career, and he has worked around the world and across several industry sectors: oil and gas industry, defence and maritime renewables. Thank you, Phil.
Well, thank you, Emma. Thank you all. It's a pleasure to present. It's a shame it's online, but I think there are some perks, so it's nice to see a good turnout. If I can really, I think, to be honest, given the quality of the presentation that just come before me, I'll try and pick my way through it and try to make some new points, really, because there's some really fantastic stuff there from Alistair, Peter, and Matt, respectively. I think I'll introduce the Autonaut USV because it's a slightly different craft than the ones we've seen in previous slides. It's a low power, low bandwidth. So the next slide, please, if you could move on, Emma. Thank you. And try and pick out a few kind of areas that we've picked up on from our perspective. But to describe it, it's quite a small craft. It's wave propelled and it has solar power as well. So that's, you know, we can put sensors on there. And the key to that renewable energy is that it goes to sea for many weeks, many months over the horizon. So you've got that instant kind of communications question from straight off the bat. And we need those communications for two things, really. There's a bit of blurring between them, but fundamentally it's command and control and data, which as we've seen before. But I'll try and pick through it, and really from the perspective of being this you know, over the horizons, low bandwidth, low power system. To the next slide, please. Yeah. So I think we've also got to pick out autonomy. I'm conscious that you know, not all USV and unmanned systems are experts in this session, and it is pretty dazzling, and that dazzle is great. It's very useful, but it's also got to be grounded a little bit. We you know, a huge amount in common with a lot of USVs. Most of our stuff is following pre-programmed waypoints. You know, it's kind of the stuff we were doing with remote control cars or toys in the 80s. You know, it's fairly straightforward, and that's a really positive thing. I see that's very positive. A tool has to be as smart as it needs to be, and in a case where we don't have the option to you know, to have the power and the push for it, we have to work with what we've got. So following the pre-programmed waypoints is very safe, it's very secure, and as long as you know your system and trust your system, it will follow those points and complete your transect for whatever the task it is to do. That's not to say you can't build smart things into it on board and from afar, but the oversight from a remote operator is really key, not least because you're updating the mission as you go. In our case, if I neglected to mention it, we're pretty slow. You know, it's a really handy little craft, but it's you know, 1 to 2 knots. It's not a fast-moving you know, beast that's gonna scare the horses. It's a smelly small craft, and it's in a lot of open blue there. So you know, a lot of it is from remote, and you've got AIS. So onboard features worth noting though, it has AIS, this identification system at sea, transmitting and receiving, and has inbuilt collision avoidance for that. And we can also track and follow to some extent. And it's got programmable exclusion zone. So hence the images here we see working around an offshore asset in the States and coming to a close pattern within 100 meters or so. I think also you've got the graphic in the right hand corner showing that through. So really sticking to that track, and a lot of that is from waypoints, but your remote oversight, you know, to make sure it doesn't stray from that, and you've got human. So if you know, react, and you can change the mission as required, but fundamentally it's got to do what it says on the tin. So moving on to data. Thank you. I think as we've covered previously, there's this kind of sliding scale really of, in the first instance, from our perspective, we've got to store it on board. Really, that's you know, keep it safe. But of course, if you've got unmanned systems out at sea for many weeks and months, that becomes a risk. You know, you're going down this one fantastic data, but you need it back at the base. You need the client, you need it in the client's. They need to see it. They want it. So it becomes significant risk. So you're moving through, and as I think it's been alluded to already, is how to get it back. What's the best communication system to get that data back? And bearing in mind the constraints that we have as a small craft. So you know, the kind of the hope to get the full time, you know, all that raw data back in real time. You know, we can do it with some of the data streams because it's very reliant on data. Something like acoustics, or in this, you can see in the slide here, visual thermal imaging here. It's not going to happen. We have done a little bit with it within Inmarsat. We've got some video threads back. We've also used Wi-Fi for that, you know, and mesh radio to get stills and video back, and big data back. but obviously where it wants to be over the horizon in the deep blue, it's not going to work. So increasingly we're looking to smart onboard processing. Deliberately phrased it because it's in edge computing and the machine learning thrown around, and we can dig into the terms of what those mean. But fundamentally, it's digging around the data on board and picking out what you really need from it and transmitting that bit back, and that gets very sophisticated very quickly. So it's picking up, I think, from one of the comments that Peter made is, big data is already here, and it's sort of stored in 1,000 hard drives already. The question is on the questions that you ask of that data, so you can get straight to it and really get the analytics right to get the data you need, and that's huge importance when you've got a system at sea collecting buckets of data, but what do you want out of it? So that smart onboard processing is key. There's another little gradation in there, which is the QC assurance check, which we find is very useful, just to know that the data, it might be being stored on board, but we want to know it's being stored on board. We need to assure a client who's waiting there for several weeks. They want to know that the data really is being stored on board and is safe. And of course, you've got the sensor integration question. This is always going to vary by the type of sensor. So it's a complementing asset. And of course, these platforms, as dazzling as great as they are just data collecting platforms. It is all about that data, as it can't be stressed enough. So moving on to the communications slide, please. So we've used all sorts, to be honest. I mean, we are fundamentally, our mainstay is Iridium Rudix. It's not much data, it's small packet stuff, and it doesn't even have to be real time, as we've seen other examples of USVs. We can update every 5 minutes, even every 20 minutes. Ideally, the remote operator's job is a very boring one in the world of autonomy. We don't want it to be an exciting, event-filled mission. We want it to be pretty, the boat just trucking along at slow pace and completing its mission. So Rudix serves us very, very well, and a lot of the boat is built around that. But of course, the flexibility, as we mentioned before as well, being able to flick as need be, depending on the environment. The operating area is really, really important. So one of our boats has recently been upgraded to 4G capability, so making use of that network coastally, Wi-Fi, radio networks, and Inmarsat if we really need to bring out the big guns. But I think it was a comment that Matt made earlier. Is satellite communications, is that the assumption that it's the be all and end all? I think it's going to have a role, there's no doubt about that. But we are, fairly flexible. It's very much dependent on power constraints, the sensor, and the operating area from our point of view. And just in terms of why we want that, to underline for the command and control, it's power management control. We need to get that data back and know how the system's doing, the diagnostic checks on the system itself, the status monitoring, and domain awareness. For us, we can't fit that many sensors. We can't really fit a big LiDAR on there, so we that awareness of what's around is very, very limited. So that's and it's also, if you have one of those sensors on there, it's a more useful sensor, if you like, that has to come off. So we constantly got those checks and balances and trying to find the right level. And for data, a little bit for CSTOMI really now, but to stress that point is that general rule, the client will always want more data and they'll always want it sooner. Of course, there are reasonable, pragmatic reasons we've got to balance that out, but that's the way it's going. That's always going to be the sort of knee-jerk response that we want more. How much data you want? We want more, and we want it now. But of course we can decycle it. Of course we can run the analytics on it and do smart things with it. But it's only gone one way. I think there might be a couple more slides to round off, but I'm happy to move to Q&A. So yeah, just a quick schematic of Autonaut. We've got it dated now, but fundamentally we've got that satellite link for C2, but we are amenable to you can see there for Wi-Fi and radio networks to pull things across, and we'll flick between the two, and then delivery of the C2 to the operator and sensor data onward to the customer. But I don't think we need to dwell on that one. If we move forward just to a little summary experience, I pushed our engineers for some their thoughts on this, and I got some interesting answers, but I tried to, so whittling it down was a bit tricky. But I think one of the comments was the connection side of it is really good. Previously, maybe it's old news now, maybe it's years ago, we worried about the connection. We don't really. It's not really a question. Don't worry about dropout so much for what we do, certainly. Nor latency for what we need. Latency isn't a massively significant issue. We're out there over the horizon. We don't get an update every 5 minutes. Well, it's okay. Obviously, different vessel, different environment, that'll be mission critical. But for us, it's okay. It's small packet data near real time. What did come through was this flexibility of commercial model. we're a small company, we're a small craft, but the missions vary hugely. So we're looking at a pay-as-you-go type of contract, or we're looking at something more substantial. So that flexibility in how we pay for our communication, how we pass on to the client is a constant issue. And I say to that, the stress about the data, demands always going up and always being more requiring sooner rather than later is pressing, and that development for smart mobile processing sensors, I think that's not going to stop. Again, those 2 points are related. But really, the next step is we heard a lot about Reading Next and all that, the certain the what's around the corner. So we're all ears really. We remain flexible and open. And I think happy to go to questions.
Perfect. Thank you very much, Phil. We're running slightly behind, but I think we're okay. I'm going to hand over to George Nicola from Satellite Applications Catapult to facilitate the Q&A. I've seen there's several questions in the chat, so George, if you'd like to start with those. I suggest if we go until about 20 past maybe, so we can give people a quick break before the next session. But George, over to you. Thank you.
Thank you, Emma, and thanks very much for those presentations. Really, really interesting points. I'll start with the questions that we have here. Try to be as quick as we can so we can kind of get to our break and recover the schedule as best we can. So I'm going to start from the top. There's 4 questions in the chat. If you've got anything, by all means, please send them through. I know certainly some of the satellite operators will absolutely be talking about some of these points when we get into the rest of the session. But let's start from the top and we'll go down. So first question here. Heard lots about the challenges and important criteria, but what is the state of the art? And is offshore connectivity currently constrained by satellite capability, or is it simply a problem of selecting the right type? So I know there's and that's an additional question. There's almost 3 questions in here. And what can LEO systems enable that VSAT can't? So I'm going to try and direct this a little bit to someone that hasn't spoken yet and will be speaking a little bit later on this afternoon. So I know certainly for state of the art and what LEOs can provide versus what VSAT can't, I think the right person to perhaps have a first crack at that is Carol Plessy from OneWeb, who's with us. Carol, can you hear me? Did you get that question?
Yes, I can hear you.
Would you like to have a first go at responding to that?
So I definitely can talk around what LEO system can do. That's actually going to be covered, I think, right after the break. We are going to talk about LEO systems, but in particular OneWeb. What I would say is that the nature of a LEO system by laws of physics, one of the asks I've heard about 3 times in the preceding presentation is the need for real-time data in large volume and low latency. And by simple facts of laws of physics, a LEO constellation is going to be able to deliver on the low latency. So we are talking a sub 100 millisecond return trip. We are able to do that just because we are much closer to the Earth. So that's as simple as that. In terms of bandwidth as well, the LEO system in general, not just OneWeb, are bringing effectively 10 times all of the bandwidth capacity currently available. So in the next 5 years, you will see the supply of capacity growing tenfold. And it means 2 things: that for your spend today, you are going to get you should expect 10 times more. Or you can spend a lot less if your needs are not growing. So yes, I think the LEO satellites are disruptor in the market. They are going to change way things are sold. I also heard a lot of demands on flexibility and coming up with commercial packages that are responding to the needs. So I will cover that a little bit on behalf of OneWeb, but this is also something that the LEO operators are looking at: pay-per-use, subscription packages, and unlimited packages. It's not one size fits all. So I think the message has been heard loud and clear, and there will be a solution, a bespoke solution for each of those various needs we've heard. So what I can't answer is what is the state of the art today, because I'm not sure I understand whether this is targeted to the operator and the technical service companies like Fulgro today, or if the question is about state of the art of satellite capabilities today.
And I think you're right, Carol, and I would interpret, you could interpret that both ways. I know Tim's on, so he could provide some clarity, or I could throw it over to Alistair and have him have a think about state of the art from Fulgro's perspective. Tim, would you like to elaborate a little bit?
Yeah, no, that's pretty much answered it, to be honest. Thank you, Carol. I guess my question was, was what applications are really challenging the current SATCOM capability, and just trying to understand, how Leo is going to help that. So I don't know. Is there something that we can't do currently, that maritime applications that we need Leo for?
I think Alistair, you probably, or Peter's thrown his hand up as well. I think he's got a view. So Peter, would you like to go first before I press gang Alistair into something?
Thanks, John. So yeah, I actually think it's all about, and again, it was reiterated by Alistair, but actually as an operator, cost is pretty much everything. It's got to be, I've for the 10 years that I've been sort of pushing technology, trying to push technology on a business case doesn't work. It's got to be the other way around. So, the democratization of LEOs, and I think, the timeliness of LEOs, it's got to be about cost, because if you think about what's out there competing with this now, we now have unmanned surface vessels that potentially could be repeater stations to land. It's another new potential competitor for satellites. You look at pseudo satellites that could also provide, comms, but also plus potentially for high resolution optical. Again, I think for me it's that mashing of comms, its capability mashing comms with EO, observational data from space, that I think is a bit of a sweet spot. But fundamentally, if it's cheap enough and it does the job, it gets through. If it's beautiful and it's fantastic, but it's 3 times the cost of how we're doing it, the way we're doing it already, it's never going to fly. Excuse the pun there.
or float, so to speak.
Yeah.
So Alistair, do you have anything to add to that?
No, I mean, yeah, I think Peter's quite right. It's an economic thing. From a technology perspective, I do honestly believe that we can do what we need to be able to do with the assets that we currently have. And Peter made a really good point in his presentation. We talked about latency. The requirement right now for latency is important, but probably won't be important in 3 or 4 years' time, because the assets and the hardware are far more intelligent. So that changes again the communications requirements and the burden on low latency comms. But the story right now is an entirely economic one from my perspective. It's not the case that we can do it, it's the case that we can't currently do it in an economically viable manner.
I think, George, just one quick thing as well, if I may add to that, is the traditional concept, and again I'm looking at oil and gas, so we're looking about traditional assets here, but the perception that effectively any data generated either in the field or on the asset had to go through the asset's control systems. The simple concept of straight to cloud now actually bypasses so much of the legacy systems that we have. So for me, I look at LEOs as they're in a really neat position now to basically really capitalize on the digital twin concept, and also this democratized straight to cloud mode of data delivery. I think it's a fantastic time, and I think once these constellations start coming online, very quickly through demonstration, we will see the true power and benefit of them, if they're the right price.
Fantastic. All right. So, Peter, while I've got you off mute, there's another question here addressed to you, but I think Matt might want to have a crack at this as well. The question is, if you have more onboard edge processed data, does this not present an increased security risk versus unprocessed data? So, your view.
So
yeah, go on, Peter. Sorry.
No, please, after you, Matt. You've got much more experience in this one.
I absolutely agree, but I think it becomes down to that cost. And one of the things I say to the customers I have is that I don't think the pipes we've got are going to get any bigger, and we need to be more efficient with the use of the pipes that are there. So data compression, edge computing, and it's that fine balance between what you need to achieve, and what is your main effort, what is your mission intent you know, and what risk will you accept? And if you're prepared to accept the risk and put the processing at the edge, it will enable you then to only send back those nuggets that you really need. And I think that's the really important part. And there's a real compromise to be had. And it's all about risk, cost, and capability, I think.
I think just to add to that, you know, the way that this sector, oil and gas, is operating right now, I think Alistair showed the sort of, you know, the near possible, or actually the possible in food grade's case because they've invested. But actually, you know, the way that most companies operate now, most service companies operate, is that they have a large ship with 80 people who are looking at the raw data as it's coming off. I would argue there's much more, quote, security risk or commercial security risk around, you know, the data floating around a ship on you know, single-use personal hard drives before, you know, rather than a pre-processing. And also, it's a mentality around how you operate. You know, is actually getting the fire, you know, it's drinking from the fire hose factor. Do we have to get all the raw data real time to understand how much do we trust this data? And, you know, what I genuinely believe is that our trust levels, as we start deploying these systems commercially, and we will see the benefits, our trust will escalate. And also, as we have a generational shift of operators, you know, to digital natives, if I can use that sort of hackneyed term, then effectively, you know, the operators of these systems will instinctively have more trust in the data that's pulled off. So they won't need to know every single 0 and 1, actually understanding that the system is doing what it's supposed to be doing within parameters. And, you know, basic things like, is it still on the pipeline or is it gone adrift? That's all you necessarily need to know. So there's an element around democratizing, dare I use the term, de-skilling through edge computing that might happen. But again, if we're looking for uncrewed systems with 0 people at sea, these have to be very self-sustaining systems anyway, that self-check themselves, you know, every 5 milliseconds. So we have that assurance that when it goes down at the end of the mission, we actually have the actionable data. At the moment, the time gaps are quite large because it's quite manumatic. So, you know, what we can prove through, you know, the enabling through satellites and LEOs and this autonomy is that actually the data that took us a month to get hold of traditionally, you know, we get within 5 minutes of the USV surfacing or completing the mission. And that changes the entire game.
If I could just add to Peter's comment there, it's also about the cognitive burden of the decision maker. And are we talking on the loop or in the loop? If we've now got thousands of these things posting data back to a single federated mission center, is that a human operator looking at that data to make the decisions? Are they in the loop? Are they on the loop? And have they got the cognitive capability to make those decisions at the time needed? Or is there going to be some augmented AI that's using haptics or noise or other types of stimulus to bring our operators to a really important decision that needs to be made?
Great, all good points. So we are over time now. So what I'm going to do is I'm going to keep an eye on the chat as the questions come in. Please let them keep coming, and we will pick this up in the second Q&A session later on this afternoon. Okay, so I'm going to hand back over to Emma. I think we're going to have a short comfort break and then reconvene. Emma, over to you.
Thank you. Yeah, thank you, George. We'll answer the rest of the questions in the second session, and if we don't have time to answer them all today, then I'll try and get the answers to you guys afterwards, after the forum's finished. So do keep asking the questions, and we'll get through as many as we can in the second session. But for now, if we just have a few minutes, 5-minute break, we'll start again at around 25 past. So I'll see you all then. Thank you very much.
Thank you. Thanks, everyone.
Global communication company powered by satellite rather than being a satellite company. And one characteristic of OneWeb by design is that our satellites are 1,200 kilometers from the Earth. And by the laws of physics, that really unlocks the low latency problem. And why latency matters, which is really part of what we've heard today, is that many applications, everything to do with real-time application, real-time data collection, real-time data processing, but more importantly, the insights you get from the data and the decision you make based on that data needs to be near real-time. So here I've illustrated what real-time means, and real-time can really work if you are below 100 millisecond latency. At the extreme end, you have the industrial IoT and alarms that really need to be processed near real time. If you want to deploy augmented reality or virtual reality engineering and remote operation, you also need to be below 150 millisecond. Voice over LTE works under 150 millisecond. When you go to remote piloting, you're still in the same range. But even when you want to work with the cloud, like public cloud and public cloud providers, really all cloud applications expect to experience a latency of no more than 200 milliseconds. And that is where the OneWeb satellites and other LEO constellation provide a real solution to this problem. Moving to the next slide. What we've heard also today is the goal of all of these offshore companies are to reduce costs, reduce risks, and to reduce costs efficiently really demands modern connectivity. So what I'm going to do is try to define modern connectivity. And here I want to say that the satellite, and we've heard it in few presentations, satellite connectivity is not the one solution to all problems. I think modern connectivity is a range of solutions being deployed together. Moving to the next slide. So what is modern connectivity? So modern connectivity starts with really having a fiber-like data speed. So we are no longer talking about kilobit per second, but really megabit per second or gigabit per second speeds. We are trying to match low latency experience on terrestrial network. Modern connectivity is also global, so the ubiquity of experience across the globe is important. But beyond that, it's also application-aware networks. So I've heard a few comments from the intervenant before me talking about the different nature of the data. Is the data transfer for an email has completely different demands and characteristics than real-time video or remote operation of a subsea vehicle. So what is an application-aware network? Is the system integration and the system integrator's capability to mark the data correctly and for the network to pick out this data and treat it differently depending on its nature. What modern connectivity also requires is that we stop really developing a satellite operator our own backbones, but really look at the giant of the telco world and deploy telco-grade backbones. Telco-grade backbones means that application-aware networks is built in, and this is terminology you'll find a lot in 5G networks. Another aspect of modern connectivity is to have an API-driven infrastructure. So to no longer rely on complex manual processes, email, Excel, spreadsheets, but really to use API platforms to reconfigure, change, and adapt the connectivity and the network to the requirements real time. And finally, what I've heard a lot today is really the need for flexibility. So having a single pipe or a single solution that solves all the problem is not really the answer. Here we want flexibility. So a lot of data when you need a lot of data, and effectively if the site is moved or is on pause, to no longer have remove that need and be able to cost effectively make the best of the connectivity. So connectivity really underpins all digital initiatives. I think that's true on land, it's true on our daily lives, it's true with all of us working from home, and it's true at sea as well. If you want to move to the next level, which is really happening now when we see all these remote and autonomous projects, not only being projects, but being executed, to really deploy this, you need connectivity at the heart of the solution. For OneWeb, what we mean by fiber at sea is to deliver 100 megabit per second speed to a single site and promise a latency below 100 milliseconds. In terms of hardware, as someone said earlier, everything is possible. There are a lot of very expensive hardware and connectivity solutions out there. Here, how can we remove this barrier and produce a low-cost hardware? At OneWeb, it's been effectively looking at the giant of telco, LTE, Qualcomm in particular, and being able to mass-produce hardware at very low cost. And here we are talking about targets which are well below half of the current equipment. And then finally, this ultra-flexible network. So how can we serve all of the stakeholders at offshore? And the stakeholders are the operational network of the technical service company, the need for the crew to be connected with home, and the need for clients to be real-time following all of the action. And all this network slicing, which is also a term from 5G, is also underpinned by cybersecurity. How do you deploy different connectivity pipes securely? And I will talk a little bit more about cybersecurity because it's not a silver bullet solution here. Moving to the next slide. So this is what OneWeb is pledging to the maritime industry. We are bringing a lot more capacity to the sea, about 10 times what is offered today on geolinks. We are promising 10 times the speed in megabit per second, 10 times improved latency, a global coverage. And what it means practically for your budget is that you should get 10 times the value, should expect 10 times the value. Moving to the next slide. So here, this is more of a projection in the future. So in 2023, knowing what we've heard from Fulgro and others, where we have today a need from half a gig a day to 80 gig a day, what will come in the future? Where in 2023, and this is more of a mind exercise, this is what we see the future to be. So an operational network on an OSV vessel, that might be an ROV or a supply vessel, we would pledge 120 megabit per second aggregate solution for the operational network. So what that translates to in terms of gigabytes, 120 megabit per second is really equivalent to about 20 terabytes a month. And that's not even on full cycle. That's not even 24 hours per 7 a day. So 20 terabytes per month, it's equivalent to 660 gigabytes a day of data. And the way we are going to offer that is through an IPVPN network, which means that the traffic is tagged depending on what it is, so top priority, middle priority, or best effort. That network is dedicated to the operational running of the platform. And in terms of commercial consumption, the customer can choose a monthly subscription, so from as low as 400 gigabit per month, or unlimited, which will effectively be around 660 gig per day. Now, we also understand that on board an OSV, you have multiple stakeholders. So when you look at the crew or even the client network, what's important here is to completely separate the crew welfare and the client network from the operational network. It could also be another stakeholder, and here I'm thinking about real-time marine data monitoring, so regulatory enforcement or protection of ecosystem enforcement, to use the platform as a data gathering platform. So just let's imagine for a second that we have a crew network, and the crew network, in addition of the operational network, would be given a 60 megabit per second aggregate throughput. And again, commercially, that would come in either a monthly subscription starting from 200 gig per month, or pay-per-use, so literally per gigabyte or terabyte of data consumed, or unlimited. And what a 60 megabit per second throughput delivers, it's effectively could be as high as 200 gigabytes a day. So this is the choice in terms of flexibility to fit the budget and the need of the customer. Moving to the next slide. So here I want to illustrate the concept of network slicing. And OneWeb is really using a telco-grade backbone and using the best interconnect and network slicing concept from 5G to deliver against the need. So the need is to separate the offshore or operational companies' operational traffic from other type of traffic. And this is just an example. So the use case is one solution on board, one set of hardware, and multiple endpoints. There is no reason why all the traffic needs to be competing with each other. Any IT solution engineering is capable of tagging, marking, and routing the traffic to different endpoints. Here, the additional layers that commercially we are also able to do that. So theoretically, you can have independent subscription, one for the operational network, one for the clients or the crew. And I'm illustrating here a green pipe, which would be routed to the cloud, maybe to the client network, and a red pipe, which is the IPVPN pipe with a lot of top priority traffic, which would be routed to the HQ of the technical services company. Now, moving on to cybersecurity, here this is more of a bit of a thought leadership approach. So what is cybersecurity? And what I want to debunk in this slide is that there is no single silver bullet approach to cybersecurity. It is not possible to go to one single provider and ask for all cybersecurity needs to be covered, because cybersecurity needs to be deployed in a layered approach. Yes, the connectivity backbone needs to be secure and the security needs to be built in. And when you buy your connectivity, you need to get credentials from your connectivity provider. Then when you buy your service and your service integration at the IP level from the service provider, you also expect the best IT practices, IT credential, and automation procedure to verify, to protect against cyber attacks. Then there is the application on top. So even if you have the best security in the connectivity and at the service provider level, is the application opening a gate to opening itself to cyber attacks? So the application provider also needs to construct an application that is not vulnerable. And on top of that, we'll have a procedure to prevent, but also to detect real-time any ingress through the application. And finally, one of the most important elements is the human elements. Even in our daily life, the weakest link in all cybersecurity approach is often the human elements. And here I will go as far as talking about banking frauds. Most of the banking frauds are targeting the human elements. The person that calls you and tells you they are the HMRC and you haven't paid your taxes, or the person that tells you that they are your bank and you need to transfer the money to a different account for a variety of reasons. Well, in an industrial approach, the human elements, and I think someone said it earlier, having a human error in leaving critical data unattended on the wrong devices or open to attack is one of the key vulnerability of the whole system. So awareness of the staff is key, but monitoring as well. And monitoring takes place with auditing and frequent certification and recertification of the system. So cybersecurity is not a one-off, it's layered, it needs a multitude of different processes, it needs certification, but constant auditing. One of the best ways to do consent auditing is to use modern techniques like machine learning that will effectively monitor human behavior and detect any abnormal copying of data or exposure of data in the cloud or on the internet. So effectively, what I've depicted here is not really a lesson I'm trying to give you. It's really what OneWeb is doing at the heart of its system. So we are, as a company, taking the same approach to protect our connectivity backbone, our telco great network, to understand the credential and the cybersecurity procedure deployed by our service providers. All our applications are constantly monitored and audited. And as staff, and the human element is also made aware, and we have machine learning automated monitoring of behavior, of data, and of staff. Effectively, that's the layer cake. That's the only way you can really real-time, constantly protect yourselves against cyber attacks, knowing that they are evolving like a virus, they are morphing all the time, and it is not possible to have a one-shot approach to cybersecurity. Moving to the next slide. So what is OneWeb doing now? I'm going to tell you more about the dates, what's coming. And OneWeb is restarting as a company. We are rehiring a lot of the staff. We've never stopped deploying our network. We've never stopped constructing our satellites. We are resuming launch of satellites in December, and then resuming a cadence of launch every 6 weeks or so. Which brings us to this time next year in November. We will have a complete service above the 50th North parallel, a service that will be delivered to fixed sites, and we will have 320 gigabit per second capacity in the region. What it means in terms of Arctic region is the fact that we have the highest density of the satellites going over polar orbit, means that we have extremely good lookup angles and very little occurrence of blockages by either landscape or structure on board a vessel. We already have 3 ground stations up and running in the region. We will have 7 ground stations up and running by next year, and the service is commercially available from November next year. Moving to the next slide and the last slide. So in summary, what OneWeb pledge is to provide the industry with at least 10 times the performance, in some cases a lot more. We are going to be alive on the market commercially in November 2021. We can provide downlinks to up to 200 megabit per second. We will provide latency of less than 100 milliseconds. And again, in latency, it's a full end-to-end network that counts. We can only control our latency. What's very important is all the cloud peering and interconnect is equally as important as a satellite link. You don't want the traffic to go twice around the world before it comes back to your headquarters. We are going to come up with an extremely flexible commercial approach, pay-per-use, pay-per-month, or unlimited solution. We are delivering to the industry multiple network slices, providing different quality of service, different priority between the traffic, but also between users on the network. And we're able to route this traffic to different endpoints for different purposes. The full maritime service will be deployed globally on the 1st of January 2023. And we do not want the hardware to be a barrier to entry. So all of the maritime hardware will be under $15,000. And this is what OneWeb will aim to do. So I'll take questions, I guess, a bit later. Thank you.
Thank you very much, Carol. That's brilliant. I'm now going to hand over to Mark from Inmarsat. Mark joined Inmarsat in September 2016 and has full responsibility for the maritime marketing and PR activities, with the objective of opening the full potential of high-speed connectivity at sea across vertical markets, including merchant shipping, small boat fishing and leisure. Mark, I know you were having some technical issues earlier, but are you there?
I am. Can you hear me, Emma?
Yes, and I can see you. Brilliant. Thank you.
Excellent. Good. Okay. So just I want to just give you a kind of an overview of the trends that we're seeing in Inmarsat. It's pleasant to hear that we've been mentioned a few times through the presentation. So this is really just to kind of look at some of the trends we're seeing in terms of data usage, data volumes. As most of you are aware, now we've got a variety of different services. Our high-speed service, Fleet Express, is now up and running on, in fact, the 10,000th vessel will be installed this month. So that's 10,000 vessels using our high-speed service, which is powered by our Global Express constellation. We then also have Fleet Broadband, which was obviously the first broadband service at sea, launched in the mid-2000s. There's still another 35,000 vessels there. And then we've got vessels that have our safety services and our Fleet One service, mainly the leisure and the fishing industry. And altogether, that's another 160,000 vessels. So we've got obviously unique insights and trends into what we're seeing. And I really wanted to kind of, just give you an overview. I've seen a message in the chat already saying, what's the impact of COVID? So I just wanted to give you an overview of what we've seen. Obviously, we'll start with the crew. I know some of the presentations earlier have been around the uncrewed vessel, but I think it's obviously very important to kind of discuss what's happening with the crew. I think you're all aware that there's been huge issues around crew changes, and crew have been stuck on board on a number of vessels. Throughout that, we've been working with a number of different maritime charities, and we've a variety of initiatives. We've actually seen voice services really kind of peak back up, and a big usage on the voice services. Some of that has been driven by the charities. We've put together various crew hotlines with some of the welfare associations, like the International Seafarers Welfare Assistance Network. And what we've also seen is that a really kind of rapid development of telemedicine at sea, a variety of different kind of COVID video calling applications, and we've provided one free of charge through our Fleet Express service. So you've seen, kind of lots of things around the development of crew connectivity and welfare tools, addressing the kind of short-term needs. But what we're also seeing is that, with the focus on crew, there's much more around, a kind of more holistic view of crew and crew welfare, from a personalized perspective as well, and giving them kind of access, to almost kind of account level around their welfare and their well-being. Once we started to have this discussion and we started to talk this through with the various charities, but also some of the world's biggest ship managers, and that's across sectors, including obviously the offshore sector, we saw that there was a real need for further look, and we commissioned a piece of research. We also started talking to Shell Shipping, who were very, very keen to kind of look into this, particularly during what they'd seen their initial kind of findings with the COVID pandemic. We produced, as you can see in the top right hand corner, we've produced a piece of research called Welfare 2.0. That actually led us on to an open innovation challenge, where we working with Shell and Thetis Consultancy, we put out a kind of a call to application providers and SMEs and startups particularly, to look at, we would give them a full access to a Shell vessel. We would put the Inmarsat technology with Fleet Express and all our digital solutions around that. And we would really kind of, give them the ability to kind of really showcase and test their application as part of a proof of concept. The winner of that was announced. It was a fatigue management startup It was actually a kind of dual solution between Canary, Sentinel, and WorkRest, startups that weren't around. You know, even in fact, actually, they really kind of came to fruition right at the beginning of this year. And now, of course, they're working with Shell and Inmarsat on a kind of proof of concept and changing seafarers' lives. Part of the judging panel, there was a number of seafarers as part of that judging panel, and obviously theirs was the winning entry because they felt that it would really make a change around fatigue management. That actually also include wearable technology as well. So, you know, we're now going through the proof of concept, but then ultimately we'll move on to hopefully a kind of deployment across the rest of the Shell fleet, but then ultimately across other operators as well. And we've had a lot of interest from other tanker operators who are very keen to see how that develops. So there is, you know, a real acceleration on the crew connectivity and the welfare tools as well. And of course, that's not going to go away. In fact, you know, there will probably be further changes to the Maritime Labour Convention, which will kind of enshrine it in law that, you know, the rights of the seafarers around connectivity as well. So if I could go on to the other slide, and then we'll talk about from a business operations perspective. So from a business operations perspective, of course, we've seen, you know, a real acceleration of remote business. So at the bottom of the slide there, that's average vessels across all our 10,000 Fleet Express. I will say on the offshore, you know, the average is around, you know, between 20 and 30 gigabytes, and we're still seeing that 30% rise. So the average vessel, you know, at the beginning of the pandemic, so in February, was around the 4 gig. That's now gone, went up to 6 gig at the end of June. So in 3 months, you saw that rise. That's now up to the average vessel. I checked it today, is around the 7.5 gig. So we're still seeing a rise in data, and that's just data downloaded from a vessel, and that's per day. As mentioned previously, obviously from an offshore perspective, you know, with certainly with dynamic positioning, those vessels are doing much more, but we're still seeing the percentage increase in the rise. So a real shift and a real acceleration, obviously, of digitalization in the maritime industry. That's also what we're also seeing, and we've just completed a piece of research on that side of things as well. What we're also seeing is it going from cost savings to remote services, you know, and agility supporting features. You know, it's already been discussed, you know, but we are seeing a real increase in, you know, getting data off vessels in real time, really becoming critical. Don't forget that, you know, in other sectors, obviously the standard of data collection has been the noon reports. Now it's actually, you know, now we're working with vessel performance software companies now who are providing it in real time, and the savings to operators is very significant, you know, both on offshore vessels and on vessel types such as bulkers and tankers. You're seeing, you know, just for one vessel performance software, whether it's around, you know, generator usage, you're seeing savings of 250,000 per year per vessel. So again, that kind of real drive to get data off the vessel in real time is really becoming critical. Next slide, please. And across the maritime industry, and we take part in the Global Maritime Forum, which is, you know, 200 plus ship owners across different types of sectors. These are the kind of, you know, the 4 pillars that have been identified, you know, really, you know, driving innovation in the maritime industry. And, you know, and obviously communications and connectivity really does play a role across all 4 of those. You know, whether it's sustainability, sustainable supply chains, everywhere you look, you hear about, whether it's the Poseidon principles, but also charterers are now being much more sustainable, and they have their own version of the Poseidon principles coming out. You know, decarbonisation today. You know, the Prime Minister announced the kind of zero emission and the focus on the shipping industry, and obviously that's across the board, not just in the UK but across the globe, and because of obviously the IMO regulations. So everything around getting data, you know, data and technology that can, drive us to a kind of zero emissions future, and the around sustainability is obviously vitally important. In terms of digitalization, so obviously the standardization of data exchanges is now becoming critical as more, as discussed again, more data is available. It has to be standard and it has to be interoperable. And I've been covering digitalization in the maritime industry for 20 plus years. I was around when the dot-com boom came and standardization was being talked there. But what you're seeing is a kind of real shift change. In industries like there's now the digital container standards initiatives and things like that are really kind of starting to take off. As mentioned, then there's the whole shift from new reports to high frequency data. And of course, as again, covered, the real emphasis on remote operations. There's of course a safety security side of things, safety, environmental. The bulk carrier off Mauritius again brought that into focus. We're seeing a real need for automated safety as well. Traditionally it's been around reactive, GMDSS alerts, and we've been at the backbone of that for many years. But what we're now seeing is can it be proactive? Can safety be proactive? So that if parameters show that for example, a vessel's draft changes rapidly or the vessel speed changes rapidly, can you alert security? Can you alert rescue coordination centers, etc., etc.? I'm not sure if you know, but obviously we work in the aviation industry, and if an aeroplane loses an engine, then obviously air traffic controls where that plane is and where it's going are all alerted to the fact. Could you do something in maritime? So there's a real drive in that around automated safety. And then of course there's cybersecurity. Carol's touched on it. This is at our backbone and very close to our heart. And we work with a number of governments around the world, and obviously try to get. We've got ISO standards around cybersecurity. We've got our own cybersecurity operations center as well, and that is kind of very, very important to us going forward. And then of course you've got the crew. The situation as discussed around the pandemic, the retention of crew, the well-being of crew, and obviously the training and education of the crew. And connectivity, just one example, training and education. Connectivity gives the ability to do kind of onboard training, video conferencing, etc., etc. And we're working with different both startups and established players in that space, to kind of then train and educate crew through our connectivity. Next slide. So what we've seen is a real expansion in the ecosystem. That communication assists. So, it's not just now the ship owner operator. We're seeing real interest from class societies in terms of the remote access. I've spoken about our application ecosystem. We'll come on to that. We're seeing insurance, safety, banks. Everybody is now starting to kind of want to kind of look at connectivity and see how that works. We're a number of the different things where we're unique is obviously we also provide dedicated bandwidth onto the vessels, and we the different pipes, so it's not just a single connectivity pipe, and each provider can have different pipes, whether that's a class society, an engine manufacturer. Obviously, and I think it was again discussed previously, it's ultimately the ship owner has to give permission, but obviously they're working with all those parties as well, and then they will provide that permission to that. And the other thing to say, and again it's been touched upon many times, is we also fully realize that it isn't just about satellite communications, and it has to be a diversity of different connectivity solutions. We've launched a kind of LTE, our fleet LTE service, which currently is in an offshore and being deployed in the North Sea and Gulf of Mexico, and that is a kind of interoperability between LTE, L-band, and our kind of high speed network, we're also, working with coastal LTE and worldwide LTE operators to provide coastal LTE as well, and coastal LTE coverage within complete interoperability between satellite and LTE. So we fully realise that, and we're definitely pushing those initiatives, and also looking at 5G, how we work with that. We're working with the European Space Agency on 5G projects too. And then finally, the rise of the startups. A piece of research we did as part of London Shipping Week last year. We actually sized the ship tech market at the moment, and that's across all ship technology and digital solutions. We're looking at around the $100 billion in terms of market size. By 2030, that's expected to go very close towards 300 billion, and startups will be a part of that. In fact, startups look to take 40% of that, and we're certainly seeing that. I've mentioned the Shell Open Innovation Challenge. We're working with a number of other startups and accelerator programs, and we're seeing a real kind of rise in startups, which is fantastic. So, final slide, please, Emma. So this is just the landscape of our application providers, and have it sitting on the SMI technology group as well. I know that there's from equipment manufacturers to yards to training providers. There's definitely a kind of a demand now to look at how do they get on board, how can they pull data off vessels, and we've seen a real growth in our application provider community. We're now over 30, with probably another 25 to join this year, and then in 2021 that could go to over 100 companies. So we're seeing a real growth in that, which is fantastic, and really kind of shows a sign of collaboration and working together as the connectivity provider. Obviously, whether it's a shipyard or a company like ABB, or startup like a Tappet or Canary Work Rest, they still need, there is a connectivity element to that, and there's also a platform element in getting that data into the cloud, and there's still a need for that. But we're never going to be able to provide those services. Obviously, we're just an enabler of those services. Okay, thank you very much.
Thank you very much, Mark. That was brilliant. I'm now going to hand over to Simon Watts from Avanti. Simon has been a principal consultant with Avanti since 2012, responsible for leading technical delivery of commercial and institutional projects, such as those funded by ESA, EC and Innovate UK. Prior to this, he was Chief Engineer, Hughes Network Systems Europe for 10 years, responsible for the integrity of all network services and solutions across Europe, and for providing technical direction to these services, leading pre-sales support and service product design. Simon, over to you.
Thank you very much. Yeah, next slide, please. So yeah, and on a personal note, prior to all that nice, boring resume description we just heard, I actually was doing some work in for British Telecom, providing satellite comms to oil platforms and gas platforms in the North Sea. And the lesson I remember from those days was how critical every element of the link was to provide the service. Basically, if the satellite comms went down, they had to stop producing hydrocarbons. So for the want of a small bit of money spent on the satellite link, they lost millions of dollars of production time. So next slide, please. So yeah, Avanti provides reliable and secure maritime and offshore comms today for day-to-day operations of a number of operators. Use cases include things like voice and data from ships, IoT applications, crew welfare, and passenger communications. Next slide. I'm conscious that we're a little bit behind time, so I'm trying not to dwell too much on some of the points. So yeah, Ka-band satellite is an ideal solution for many maritime and offshore communication needs. I think one of the things, if you were to truly debate this, is different satellites are good at different services and solutions. No one size fits all. But today we can provide cost-effective, reliable, resilient communication to offshore assets with both inherent and inbuilt security, highly resilient and so forth. Next slide. So how does it work? Well, very simply, left-hand side, World Wide Web or private network connects through our operations center to the satellite gateway over satellite capacity, through satellite terminals to the offshore systems. Gross oversimplification, very much a commercial slide, so move on to the next one. A little bit more detail, and for some reason our marketing team have reversed the order, so we're now moving from right to left, not left to right. You can see that there's a lot of resiliency built in. We have multiple connections between our hubs and the core network. We have multiple gateways, we have multiple satellites. You need all of those elements in your network to provide the secure and reliable service that we offer, backed up with SLAs, offering multi-megabit services if you want it, or slower speed if you don't. Next slide. So a couple of use cases from Avanti today. In the North Sea, we provide sort of data services for a major Scottish ferry operator. The ship operation bandwidth, which is an IoT type of ship monitoring type of service, and that's provided on a separate and secure network element, separate VLAN, to the passenger network, so passengers can post nice pictures on Facebook or Twitter of their ferry journey if they so desire. Another thing that Avanti does is we help with the with oil exploration, oil production. In this particular case, we've called out. We provide satellite capacity into coastal waters of Iraq to help them manage their assets. We use easy to install and simple to maintain equipment to provide the service. Clearly, these are not the most accessible places, so you don't want things to go wrong too often. Next slide. So this is my passion at the moment, 5G, in particular the standards-based integration of satellite services and satellite equipment into 5G networks. So, for example, we in Avanti led a major project with the EC called Sat5G, where we prototyped and developed a lot of ways that we could do that, and we demonstrated that very, very effectively in that project. Follow-up work with 5Genesis to show how we can support end-to-end slicing across satellite connections. We're going to develop that further with European Space Agency to allow dynamic slices. Now, one of the key things about 5G is inherent within 5G standard set is the ability to create what they call network slices. Many of you have probably heard of that. If you haven't, basically it means separate networks managed by the entity. So we would provide capacity, but the management of that capacity would be done by whoever owns that slice. So that's very powerful. You could have separate slices for different people providing different services to the offshore locations. Avanti is quite vocal in a number of trade bodies in representing the building a good roadmap for the standards-based integration of satellite into 5G. We recognise there are LEO, there are MEO, there are GEO. We're not the only GEO operator. We like to think we're the best, but who wouldn't? All have a role to play in building a roadmap, and we support standards efforts in 3GPP, in ETSI, and regulatory issues in the ITU to develop that. And clearly we've got relationships with a number of mobile network operators. I can't tell you anything about that, hence the safe, but we do listen very carefully to what they're telling us. Next slide. So this is a fairly generic slide, not specific to the maritime world. These are some of the areas that we are looking to work with MNOs and also private network operators, because 5G isn't limited to the Vodafones of this world. It can be a private network solution, an alternative to Wi-Fi on the one hand, and Zigbee or LoRaWAN or any of the low power radio solutions on the other hand. So these and you can create services, separate service separation to support all these different things for remote locations, the moving locations, temporary needs. Satellite is very good for temporary connections. It will provide multiple private networks. You can use one area where I think Geo has probably got a natural advantage over LEO is in the content pre-positioning in caches. You can push the same content to multiple locations. Plane operators are considering this, using it as a way of streaming real-time. Basically, you can watch the football when next time you can get on an airplane. Ultra reliable, low latency communication. Well, clearly, Geo is not very good at the low latency, the 10 millisecond thing, but it has a critical role to play in the ultra reliable place, providing alternate capacity. And then the massive machine type communication at the bottom left, environmental. You could, and the point here is you can either do direct to device, where you have a small specialist antenna connecting one or two monitoring devices directly to the satellite and back to the core, or you can aggregate multiple devices locally and send them back over a more conventional connection. So hopefully those use cases that are illustrated there give you the sort of context. Going back to the ultra reliable, it's probably worth dwelling on the point that these business critical applications can be readily supported by modern Ka-band high throughput satellite services like Avanti's, for example, providing critical national infrastructure monitoring capability. And with that, hopefully I've allowed a little bit of catch up in time. Thank you very much for your time.
Thank you very much, Simon. That's brilliant. So last but definitely by no means least, I'm going to hand over to Douglas Watson. Douglas is an accomplished commercial leader and consultant and has extensive experience of executive level leadership within the technology sector. He was part of the Compondex management team acquired by Ericsson, which he grew from 30,000 turnover to its eventual sale of 20 million. Doug has founded and run several international businesses in the non-technology sectors, including plain sailing, ocean racing, environmental research, Carpe Diem, and Ericsson Maritime. Doug, over to you.
Okay, thank you very much. I just want to come at this from an end user perspective, actually. So I advise a board of directors. One is a major UK port operator, and the other one is a bulk carrier in Asia. And basically, what they both said is that their assets are their assets. So it doesn't really matter whether the asset is at sea or at land. It's a business asset, irrespective of location. And the other thing that I've learned from them is that there's an expectation, right? There's an expectation that what you can achieve on land in terms of IT and applications, there's an expectation for that now to be implemented at sea. And we've heard some great examples this morning from Alistair, Matt, Pete, and Phil. That expectation is becoming real, and certainly from my experience, I've seen great companies, SISP Technologies, who have a great compression algorithm used on land, and now a great application that can support either ubiquitous connectivity for ROVs at sea. So basically, all of this leads to applications that allow a maritime operator, ship operator, or an offshore operator to integrate whatever their assets are into a holistic business model. And if you go on to the next slide, Emma, I just want to show an example of that. I'll talk around an example of that. So this slide is great because it shows you the complete core process and all of the players and actors who are involved in a vessel coming into port and departing port. So if you're a bulk carrier, you want to use your communications to, whether it's operations on the vessel or engineering processes or the business processes of getting your goods from that vessel onto shore. There's a whole communications ecosystem that has to be supported. And as Carol and Mark and Simon have alluded to, it's not one size fits all. It's not one player. The satellite and the connectivity plays a part, certainly, but all of these players, you saw from the last slide, all of these players need to communicate effectively with each other. And that, from an end user perspective, enables them to get a closer relationship to their customers. Certainly as a bulk shipper, you want to make sure that your vessels are discharged efficiently and that the customer is informed efficiently that has happened. So I want to give a great example of a vessel. I had a conversation with an organization that you may well know of called Maersk, and we started off with a problem, right? We started off with, we don't have enough capacity and we need new SATCOMs. And so the discussion went from what it is they want to why is it they want it. So understanding the problem was key in enabling us to understand that they wanted to have more efficient way of discharging their refrigerated cargo. And that led to, well, actually they needed to understand what was in their refrigerated cargo containers on board the vessels. And so again, it led to a far more consultative approach, whereby we started off looking at SATCOMs and we ended up talking about refrigerated asparagus. Led to a complete end-to-end IT solution that encompassed the satellite comms, but also encompassed a whole bunch of other things that Carol, Mark and Simon have alluded to as well, ranging from cybersecurity through to IT systems, through to crew, through ultimately to sizing the satellite connection. So all that to say, in summary, is that the discussions that we've had this morning, the applications that we've discussed, Pete, Phil, Matt, and through to the more operational operator side, all for me help to focus on the customer. And my one parting shot is that we have to consult. We have to consult, not sell. And in consulting, you understand the problems. You understand those problems of the customer by both empirical or observational or anecdotal evidence. But ultimately, we need to find a solution that also adds up from a financial perspective. And both Phil and Peter touched on the business case, and the business case has to stack up for whatever solution that's been implemented. So as mentioned before, SATCOMs are a great enabler, but the real value in SATCOMs comes in its implementation for the business. So that's all for me, and I look forward to any questions.
Perfect. Thanks very much, Doug. So I just want to say thank you again to everyone, all of our speakers today. We're again running a bit behind schedule, but we have a little bit of time to answer a few more questions. So I'm going to hand back over to George, if he's there, if he's available, to run through some more of the questions that we had from earlier. Thank you very much.
Thank you, Emma. So I'm looking at the chat page. I haven't had any new questions, but I wanted to just add a little bit of my own kind of conversation to the presentation. So very, very interesting conversation. Certainly from my time in the satellite industry, I would absolutely go with there isn't a one size fits all. And certainly we see at the Catapult, We see multiple types of applications being brought to us from users, from end users, looking that have problems to solve. Interestingly, shipping is at the top of the agenda at the moment, with the particular call where we're looking to optimize logistic paths and let freight owners, freight forwarders, port management understand the logistics of where these containers are, which ones are empty, which ones are full, which ones have made it onto the ship, which ones haven't, in order to optimize supply chain. So very, very, very current conversation to be had. Again, no new questions. So I'm just going to go back through to see if we've covered some of the questions from earlier on. So one that I think actually hasn't been answered is a mention from Jonathan Williams. I'm not sure if he's still with us, but the question was, diversity was mentioned, and what is the status and standards of interoperability in the domain? So interesting question. I'm not sure if Jonathan is still with us. Jonathan, you still with us?
I think he had to leave.
I think
Unfortunately.
so, okay, so who would like to have a go at that? So let's think about interoperability of networks or interoperability of solutions. So do we still have, I'm looking through a screen of names. Do we still have Matt with us from Paris, or perhaps Peter? I see Peter still with us. Peter, do you have any thoughts on that?
I suppose the question was, sorry, that was about diversity, was it?
Yes.
I suppose I'd have to ask what diversity meant.
Yes.
So I don't know, George, could you interpret that one at all?
I'm afraid I'm giving you everything I've got.
Diversity is quite different to me, actually.
Yeah. I see what, why don't we can take that one offline and perhaps go back to Jonathan.
Well, maybe I could say something from a 5G context.
Please, Simon, please do so.
Yeah, so if I go back to my very first statement, going back to North Sea, in those days we used diversity to mean different paths for connecting. So we used 2 different satellites, we used 2 different teleports to connect to the oil platforms to minimize the risk of connection failure. Diversity in the 5G world means you use whichever access path is available. So satellite, indeed multiple different satellite options, all become part of this diverse framework, so that the service naturally takes the optimal path that it can. So that's something very much that 5G will help deliver. Hopefully that gives a kind of an answer at least.
It certainly does. Right. But, I have a question, new question from Neil Tinmouth, which is actually, I think, really, really good. So and very relevant to the speakers we've just had. So I'll read it verbatim, but doesn't take much interpretation. As we move towards uncrewed solutions, is the industry looking to move from high download speeds to a focus on increasing the upload speeds? So an interesting question, one that I certainly had looked at when I was geo operator and a LEO operator. So really, really interesting. I'm going to throw that first to Carol because I know the OneWeb network is different, and then perhaps if Mark's still with us, he could give us the Inmarsat view as well. So Carol, would you like to go first?
Sure. So yes, we often talk about high download speeds, but in the particular offshore industry, it's clear that it's data off the vessel that really matters in terms of bulk of data. I would say that for the crew, so if the crew is the driver for the download, if we remove the crew, I think the connectivity is more symmetrical in terms of requirements. That's why for OneWeb, we would not consider upload speed of less than 10 megabits per second. For this industry, I think anything under 10 megabits per second starts to be very challenging to send 100 gigabytes a day. That's effectively very challenging. So we are looking at subscription that can be symmetrical, although for now we are going to market with a ratio of 5:1 in terms of download to upload, but we will be considering the minimum upload around 10 megabits per second for the maritime industry.
Thank you, Carol. So Mark, from an Inmarsat perspective, what's the view and the usage? I mean, you had some usage numbers in your slide deck. What's the view? Is it becoming more symmetric? What's it looking like?
So obviously the stats that I provided were just download stats, but our upload stats are following the same trend. I think, you know, Carol's right in terms of when, you know, certainly if you're looking at the kind of unmanned and some of the vessel types that we've talked about earlier, you know, there will be more emphasis on upload, and we're, you know, kind of we're prepared for that. But what I would also argue is that there's still, you know, what we're seeing is the kind of virtual servers and the updates of, you know, continuous updates going on. So there's, you know, there's going to be demand on that download even with the crew out, you know. So I feel that there may be a closing of the gap, let's say that, but, you know, there's still, you know, that kind of rapid demand for download, certainly, you know, within the next 5 years. And, you know, we're building our connectivity and our plans all around that.
I think just if I may add, George, to echo Mark's comments, Mark has a very good point. Even if you remove the crew, and I think it was Peter was talking about edge computing. It just happened that I've spent 2.5 years on the edge computing project, and to my dismay, the amount of uploads and constant traffic required to manage an edge device is not to be underestimated. So whilst you may remove the crew and remove Facebook and TikTok traffic, you might replace that download traffic very much to the CPE, to the edge device, to keep it up to date and in sync with the core, to keep its configuration and its integrity. So I think there will still be a balance towards higher download than upload. But as Mark is saying, the trend is both are increasing incredibly rapidly.
Interesting. Thank you. Emma, I'm conscious we are at time. Do you want to wrap up, or we've got one more question from Sean?
Yeah, I think if everyone's okay, just go for that last question and then I'll wrap up.
Okay, fair enough. So our very own Sean McCarthy has asked, are there ways to model and simulate the comms and asset networks to find optimum solutions for a variety of uses? So Sean, you're more than capable of pointing this one to where you'd like it to be answered. So why don't you do that for me?
I mean, a lot of people have mentioned about digital twins and the variety of solutions, both on the hardware, the assets that are being deployed. To me, it looks like a complete nightmare of trying to find out what would be the optimum solution for any given situation. And I might be being naive here, but can it be modeled so you have your assets, your comms, put in the, you know, a sort of a MODAF type architectural framework that looks at costs, bandwidth, everything in it, or is that done every day and I'm just not aware of it? Maybe I was going to say if Matt's still around, or Peter's there, or Alistair's
got his hand up. He's volunteered for that one. So
all right, yeah, it's a really interesting point, and you know, I come from an offshore survey background where we typically work on error budgets for, you know, the sensor data we collect. I would say that one thing that's changed over the last few years, and I briefly mentioned it earlier today, but it's the concept of a communications error budget and a communications strategy. So, you know, not only do we work out how we're going to achieve the project and what sensors and what tools and what vessels and everything else and how we go about that, we also actually now look at that and say, right, these are the requirements. What is our comms plan to enable us to do that? Is it 4G? Is it 5G? Is it, you know, maritime broadband radio? Is it a direct link to the vessel, or you know, or anything else? So we actually now do look at that, and a lot of the time it's a combination of lots of those, as I think it's been quite clear from the presentations today. But that is now on a project by project level, something that we as remote operators now really do need to consider, and it becomes very critical to our project planning. not only from an implementation point of view, but also, you know, I hate to always bring it back to cost, but it's something that we need to think about even at the tender phase as to how we would approach it from a technical perspective with the sensors and payloads and assets, but also from a comms point of view. It really is at the forefront of our planning now.
Thank you, Alistair.
Peter was going to say something as well.
Yeah, just very briefly. I mean, you know, we think about unmanned vessels or uncrewed vessels, and there are actually very few of them around in the world at the moment still. So, you know, we're genuinely on the sort of bleeding edge of this technology about how it's going to be used. And I think there is definitely a massive element around the fleet planning, if I can use that term, and fleet simulation of the transition from crewed vessels to uncrewed. You know, we're at the very, very start of that journey. And I think that's what's so exciting at the moment, is that we are comms and data, everybody knows, is a massive speed bump in the adoption and uptake of this technology. So I think, you know, I think there's an opportunity here potentially, you know, to think about actually the data being perhaps one of the first things that's analyzed, because, you know, as Alistair said, data is money, data is the new oil, you know, so actually I think what would be quite refreshing is to actually focus on that capability and the optimizing the networks from, you know, starting off with the data, because that's really why we do it. You know, I mean, we all love floating yellow, you know, vessels as well, but really it's about the data. So actually, I think there's an opportunity there to take lead, you know, potentially take a lead on that. And it was interesting, you know, looking at Simon's great work in you know, Iraqi oil fields, which are not known for their ease of operation, where, you know, I think the term edge computing was possibly invented as well. You know, I think there's a lot of lessons, I think, from the group that we have here that could probably contribute to what would that look like? You know, how do we model an optimum solution? There is complexity, obviously we have to make it generic, but I think the other element of this is that as we try and build these systems to be multifunctional tools, that actually we have the additional complexity of a lot of other things being added on. So it's trying to be a jack of all trades to really get the value and to justify CapEx expenditure for these very expensive units. So it's a really flexible plastic model at the moment that I think we're looking at. And we're just at the very start, maybe focusing on data. You know, I mean, the revolution that's going on here, you know, seeing what Carol and Mark are doing in the space with their new systems, you know, might be an opportunity to push the discussion straight to data rather than, you know, the building of hardware and systems to collect the data.
I would echo Peter. This point is really important. I think a good use of communication starts with a good understanding of the data needs, the taxonomy of the data pipe, the use and the value of this data. So ranking it by value and understanding what is going on the offshore platform today, what is coming in, what is going out. To have really a good understanding of that is a starting point, because there is no one single shot solution. I think there is a place for the LEO satellites are bringing a big revolution to the service, but it's not displacing other solution as such. Their Wi-Fi, 4G, geo links are all useful. They have all their unique selling points. So it's quite strange maybe for me to say that, but I think a good comm solution is an aggregation of solution and a mastery of the data and the management of the data pipe and the IP pipe. So effectively, what the industry is looking for is a superb system integrator, whoever that might be.
Absolutely. Okay, fantastic. I think so. We're well over time now. I thank you all very much for your time and your comments. Totally agree. Data is key. I think that's the message we need to take away from this. So Emma, I'll over to you to wrap up.
Thank you very much. Thank you, George, for facilitating that discussion as well. I'd just like to say thank you, everyone, for getting involved with the discussion and for joining us today. I appreciate everyone's busy, but I hope you find this as useful as I have. There's potential that we could arrange follow-on meetings for this. So if there's any specific aspects, I mean, we've spoken about data and things like that. If there's specific aspects that we want to have a follow-up meeting on, then please let me know. And please just get in contact if you have any more questions. If anyone wants introductions to any of the people who have spoken today, then we're happy to facilitate that. But yeah, just thank you. I think that's enough. That's enough from me. We've run out of time, but thank you everyone for your time, and I hope you've enjoyed the event.
Thank you, Emma.
No worries.
Thanks so much. Real pleasure.